Once again, here's a quick look at the AAS postulate and a reminder of what it means. It's exactly like it looks. AAS means we have an angle, followed by a side. An angle and an angle, followed by a side in this triangle, congruent to an angle, followed by a side in this triangle, is a way to prove that those two triangles are congruent. Using only the information in the diagram, what's the easiest way to prove these two triangles are congruent? Once again, our options for proving triangles are congruent are 4 options: SSS, SAS, ASA, and AAS. Okay, again, looking at this using only the information here, I can mark this side as congruent because notice it is shared between the two triangles. So I have for each triangle an angle, and a side, an angle, and a side. I did not have 3 pairs of sides, so I can't use SSS. I didn't have 2 pairs of sides, so I can't use SAS. So my only option is either ASA or AAS. So the most obvious thing here, notice I have an angle, followed by a side. If it were going to be ASA, it would have to be the side that's between the 2 angles that I'm using, and it's not. Okay? It's a side that follows the 2 angles in the triangle. So I can prove by AAS would be the easiest way to prove these 2 triangles are congruent. Alright, next example. What could we use to prove that these 2 triangles are congruent? Okay, so again, look through your options. You have SSS, SAS, ASA, or AAS. Those are our 4 options. Then look at your figure and see what's marked. On this figure we have an angle, a second angle, and we have a side marked congruent to an angle, and a side. So for each individual triangle we have 2 angles and a side marked. We don't have sides, side, not enough sides for that, and we don't have enough sides for side, angle, side, because what you have has to be in each individual triangle. So in each individual triangle we have 2 angles and a side, which leaves us with these 2 options. When we're deciding which of these 2 options it is, we take a look at where the side is located. Is it between the 2 angles, like this is between the 2 A's, or is it after the 2 angles, like this is after the 2 A's? Okay, so take a look. Where is the side located? Well, here we have an angle. If the side between them, it would have to be this side right here that's connecting them, and not this side that follows. So it's not ASA, it is AAS. It's 2 angles followed by a side. Alright, how could you prove that triangles QUR and SUR are congruent? Alright, so let's take a look at what we have. How could we prove that QRU, that triangle, is congruent to QUR is congruent to SUR? Well, a few things I can see right off. I have a right angle here, which means this must also be a right angle because they form a straight line together. Okay. The next thing that I notice is UR is shared between the 2, so it is congruent to itself, and I can mark it as a congruent side. Okay. So what do I have now? I have an angle and a side. Well, that's not enough for any of my postulates or my properties. It's not enough sides for SSS, it's not enough sides for SAS, and it's not enough angles for ASA or AAS. Okay, but notice they did give me one other fact here. Okay, and that is the fact that these 2 angles are congruent. Well, let's say this was 120 degrees and this was 120 degrees. Notice they form a straight line, a linear pair, with the angle next to them. We had a theorem that said that if 2 congruent angles form linear pair, the angle they form a linear pair with is congruent, which is the case. Think about it. If this was 120, this would have to be 60 to make 180. Okay, and if this is 120, this is 120, and that would have to be 60 also. Okay, so whatever these are, they form a linear pair with these. That makes them congruent. Now, do I have enough for any of my postulates? Let's see. Now I have in this triangle an angle, and a side. Okay, still I can't use SSS or SAS. I don't have enough sides, and I'm not going to be able to find enough sides. But I do have two angles. Is it ASA or AAS that I'm working with? Well, notice I have an angle followed by a side, congruent to an angle followed by a side. So AAS works. However, remember that anytime we can use AAS, that means we know two angles in the triangle, and the third angle theorem allows us to know that if two angles in a triangle are congruent to two angles in another triangle, the third angle pair is automatically congruent. That's the third angle theorem. And now I have angle, side, angle. Angle, side, angle. So actually for this figure, both AAS and ASA would work to prove they're congruent. Okay, here is one more figure. What could I use to prove that these two triangles are congruent? Well, again, here's our list of options: SSS, SAS, ASA, or AAS. None of the sides are marked. Are there any that I can mark? Yes, I can mark this one down the middle because it's shared by both triangles and it's congruent to itself. So I have one congruent side, not enough for SSS or SAS, so they're both out. I do have two congruent angles and a side, so ASA and AAS are both on the table. Okay, so I have ASA. Notice I have two angles and the side between them, which gives me ASA. So the most obvious choice here is ASA to prove they're congruent. However, remember again, we do have that third angle theorem, which says if you have two congruent angles in a triangle, then the third pair of angles are automatically congruent. And now I also have angle followed by a side, congruent to an angle followed by a side. So once again on this one, AAS is also an option. Because of that third angle theorem, AAS, anytime you have it, ASA is also going to be an option, and vice versa.